Okay, put myself in that little corner. All right. So 2-1 to 2-3, first half, Sir kicks or ticks. Then yesterday I told you draw a line in the sand, not Sir kicks or ticks, because you don't even have a coordinate plane, so you had to play Sokotoa. Oh, you know what? I'm glad I just started this now because I did talk about some homework. And again, so happy that I am in one of the tutors. And I'm happy that it happens right before CAT because it actually gives me ideas about what I should maybe discuss during the day. I get CAT students every day, and they're really cool to deal with. And so, homework yesterday. All right. There were a couple things at the end a little tricky. And this is the people that actually read and did their homework and gave it a try. So the first question, the building, right? People shake your head about the building. You got a building, you're in the middle on the other side of the street of a building, there's an angle of elevation and depression. Anyone? 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 Okay, well, this is all you had to do. So the angle of depression building question, they tell you how high above the ground that you are. So you can use a rectangle to find the opposite side of that triangle across the street for the angle of depression triangle. Are you with me? Because all you had to do for this question was use that information to find your line of sight, how far you are directly across the building, and then do step two, use that you just found to solve the top triangle. That's all you have to do. It's a two-step question. All right. So, and I would hope there'd be more problem solving that we could figure that out, and not just I did an exact example just like that. Now you can do the homework with different numbers. That's been happening too much in our educational process, where if we don't do exactly the type of question that you are assigning for homework, then the students want to call their lawyer and say this is unfair. All right, so I really want you to think more on those questions. That's all that really happened on that one. Do something, not nothing. Right, and that one just creates two things. Here's the next thing. Pyramid question. Anyone shake your head? Pyramid, pyramid, pyramid. Okay, I got the numbers locked in my brain. They have a pyramid with a base that's square. You got to read the question. It does say that. So that means all these corners are right angles. Does anyone know? This proves that you've done the question. What is each side length? 3, 2, 1, go. 700. Good. So that means you did do your homework. And if you didn't say that, you didn't do your homework or you didn't try to read it. All right, let's hold off on that. In the middle, they do have that height, because that would be in the middle of that square, the height of the thing. Do you remember how high that is? That's the other number given. 200. Nice. Those are people that actually looked at this. What you got to do is extract that height triangle out and just put it two-dimensionally on your piece of paper. You don't need the whole drawing of the whole three-dimensional image. Okay, back to the 700. Did I do that wrong? I think I did do that wrong now that I think about it, because now I want to draw this. So we have a square base, 700. And then I was talking about the diagonal. So actually, I think this is a little bit trouble. Now you got to kind of think that this is the height, and then we had this thing right here, right? So that was the height triangle, correct? And then this was, so that's what I'm going to pull out of here. So this is 200. I may have screwed up the rest of my my students on this one, right? Because that isn't this right here? Isn't this from here to here? Correct? Is it to the middle of that side? Isn't that correct? All right. So if this is 700, what also happens on this is this cuts this in half to be 350. So these are 350 here and here. So now I'm trying to think about this a little bit further. Does that mean, oh, yeah, that's even easier? This side right here is actually half of this 700. So this side is actually 350 here. I was telling them this diagonal, which I also know about this diagonal. You know what this diagonal is? It's actually, this is a 45, 45, 90. So what's this diagonal? How far is that diagonal? How big is that? A, root 2. So 700, 700. Anyone? 700 root 2. But now that I think about it, I don't even need that little dotted line there. I just needed this, which is half of 750. Whoopsie daisy. The other students will get this wrong. You have actually everything you need in order to solve for that angle of elevation right there. Okay? Got it. I mean, that's it. That's easy. Okay? So I screwed up. I was thinking of the diagonal, which has nothing to do with this height triangle here. If I have that correctly. Am I right? Do you have the drawing there? Isn't that drawing? This goes from here to here, which would actually be half of 700. So, ooh, even easier. So all the other students will get that wrong. That's Mr. Samuelis's fault. Okay, but anyway, just some problem solving. That's all we want there. All right. So all the other classes I did discuss those two again in a positive way because those were the ones in tutoring that wanted just some reaffirmations on that, and it's good. It's all good. But again, try to problem solve and think on questions, and those that can actually figure that out on themselves without anyone else, that's who gets the A's. I mean, that's really what it is. Those that can problem solve and actually, do those things. I can get it down to that easy. What was that? That a tangent? Isn't that a tangent of angle equals 200 over 350, right? And then inverse tan 2 over 350. All right, now let's get into the brass tacks of it. Switch gears. All right. So you don't even know what this is here. I'm going to go ahead and mark this up here. So SOHCAHTOA 2425, this weird bearings kind of idea. My wife's actually doing this right now too. It's so funny that we're almost teaching the same thing at the same time. She teaches a pre-calc honors, but then this weird class called Algebra 2 that the rest of the state of Illinois has besides Lockport. Anyway, bearings. Okay? So here's one way to do a bearing, and this is for planes, trains, and automobiles. Anyone ever see that movie? Nice. If you prove it, what holiday is that? What holiday? You know what holiday that takes place in? No, it's one of the only. What's before Christmas, everybody? Thanksgiving. It's one of the only Thanksgiving movies out there. It's a great movie with John Candy and Steve Martin. Oh, can I mention? Have any of those guys been canceled by culture? Because then if you mention a canceled culture person, then you're the devil as well. All right, that's how the world works as well. Anyway, here's how it works. When you name a bearing from 0 to 360, this is the direction that it means it's going. So I'm going to put my position right here. You don't have me know this in class where I am relative to Chicago, but isn't Chicago over there about? Wouldn't you say Chicago's like kind of that way? Yeah. All right, so that would be north. When we call Chicago northish, let's pretend that's north. So my first direction going 32 degrees as a bearing means if I got a protractor and measure, I'd rotate 32 degrees this way and start walking. And that's my direction. That's my bearing. That's what a bearing means. Where am I going? All right, so there's a 32 degrees bearing, which would be also called north what? Northeasterly direction. There you go. So somebody, I'm just the informant, decided this is one way we could say the direction somebody's going. Hey, let's base it off of the north axis only, and let's go clockwise. There's the next thing that's rough. This is going off of the north axis in a clockwise, not counterclockwise direction. Only. So when we're doing bearings, that's what they decided. Because in the normal world, clockwise seems to be the norm direction because that's the way a clock goes. In the math world, how they name quadrants 1, 2, 3, 4, normal is counterclockwise. Positive is normal. This is where you got to separate your files. You got to separate these two differences, and I can't help you doing that. I can only inform you that this is what you need to do. All right? That's all I can do. All right? So 164 is almost which direction? Almost south, but you would argue southeast, right? And then north 229 is southwest. And then the last one's northwest, in a way. Not in a way, it is. All right, going in the northwestern direction. Okay? So this is one way. Here's a second way. Let me hide this. I don't like that that's even an option. I like this method better. And you might want to write these down. I mean, this is your notes, at least having an example of all these. I like this one better because, and I did write this down on my like copied notes here, or what I brought over from old notes, but this is always between 0 and 90 degrees because it's more specific. It's more specific off of either the north or the south. It will be listed with some, letters. So what this means is north 42 in an easterly direction. So off of the north axis, you go 42 degrees, rotate, and then you go. That's where you're going, all right? Or that's where the object is that you're looking at in that direction. And by the way, I guess another thing to help you on, this is like your bird's eye view looking at Earth, from space. So two-dimensionally, we are seeing everything. Even if the plane's above, like the ground, you only see them as two-dimensional. You understand what I'm saying? Right? So it's like looking at a map, like you're way above everything. Anyone ever see radar, the blip screen? Beep, beep, beep. I think that's what's happening. I don't know. I think that's where they're saying in location to, like, you have all the cities, and then you see this beep, and you see this plane. But they also probably have something else for how many miles above Earth it is or so. Feet, probably feet. Okay, so the second method is direct, or it could be south 31 east. So off of the south axis, rotate directly 31 degrees. This is southeast. That's another reason I like it. It shows that you're going southeast. Southwest, northwest, I don't think I have to say anything further on that. So when I go back up to this, the difference between 2.4 and 2.5, and I actually wanted to highlight this differently. The second method I'll highlight in green, because the first method is off of the north axis only, and it has to go in this direction. So I want to throw that in there so you understand the difference between this and coordinate trig. Positive angle, negative angle, you have two choices. This one, it always goes that way. Second method, I really can't do much other than say it's either off of the north axis or the south axis. And it can go in any direction, but it's always a positive angle measure between 0 and 90. All right, so those are the difference. Yellow for the first method have to go this way. Green, it could go any way, and it's always going to be between 0 and 90. All right? And now I'm just the informant. But we do want to do this because trig is involved to find out where things are located or how far they are or what's the angle between them. And you know what's happening? That's what the instruments, that the people that matter, that look at stuff, the instruments have that in the programming, everything that we're doing right now. So that's got to be the truth. All right, so I give you 5 and 7. You're going to do 6, 9, and 11. And I did that so you can look at the odds if you so care to. Observer from a radar station sees things that are located at these positions. Well, now they give me coordinates. Is this coordinate trig? No. It's just playing around with, can you spit back out what I just told you as far as what would the bearings be in both methods? So first of all, there's negative 40. And I guess here's the station. So they see this over here in this direction. Sometimes they say this, then that thing is due what? Due directly what direction? Due west. It's due west. All right. Sometimes they just say that due west means directly west. So you would know where that's located compared to somebody else. Okay, so our two methods, which I got to erase this. This was an accident. Sorry, it's not COVID. Everyone just relax in the internet world. Cancel him. All right, north, south, east, west. What a world we live in. All right, north, south, east, and west. Yellow direction. Okay, everyone, just to spit back information. Which way do I move? Clockwise or counterclockwise? 3, 2, 1, go. Okay, and then everyone should know the answer. 3, 2, 1, what is that answer? So that's a bearing of 270. So the first bearing method, 270 degrees, is due west. The next one, we got choices. It's just because I'm directly due west. And the rules for the second one is between 0 and 90. So here's the first one. It could be this, which I did color in green. What is that? What's the first letter I have to write? 3, 2, 1, go. N. How many degrees did I move? 90. And then in which direction? Or technically, I don't know why that's still, okay, there we go. Technically, just to color code this different, it could be that because this is a unique question where I could answer both of these. Because 90 degrees, it's one or the other. All right, due west. Move over here in my little corner. All right, then the next one, just a little fun, maybe with a little connection to what we've done coordinate trig-wise. It's my pen acting up. It always does these things. And then this is where the object is that we're looking at, whether it be a plane, train, or automobile. Okay. Let's do the second method. I bet you we can figure that out really easily. What do you surmise this angle has to be when this is -5, 5? Oh, and then by the way, if I went back to the origin, what would the length of that side be? 5 root 2, because what kind of triangle is this? 45, 45, 90. So if that's 45, what's that green angle measure? 45. So how would you write it? Well, we got to put the NSWE thing there. And then the second one is north 45 west. And then I'll highlight that in green. Now that we got that taken care of, everyone should know off of the north axis what this should be based off of what we learned in coordinate trig, because we've done these moves before and asked for this angle measure. I stopped there for a second, and now I'm going to keep going, and now tell me what that full angle measure is. 3, 2, 1, go. Well, no, there's no north or south. There is just 3, what? 15. That's the 45 in quadrant 4 when we were dealing with coordinate trig. So it's the same move, 270 plus another 45. Break down the numbers into, some people are struggling and putting 305 for that. 270 plus 30, right? 270 plus 30 is 300, and then you have 15 left over. Break up 45 into 30 and 15 in your head, because I am getting odd answers for that, weird answers. All right, and then here's the next thing. In the homework, I assigned 4 questions. And I swear to dog, if you don't listen to me on this, then you're causing your own failure. Don't get your lawyer against me, okay? It's you. It's not me. I have literally assigned you 4 questions where the drawings are provided. The very first thing you should do is hand your book to a parent, guardian, or, not your dog. I don't think they can do it, but, a sibling, and say, go to that page and say, cover those drawings for me with these sticky notes, so I don't see the drawings. So your question should look just like this. You see that? This should be covered. Got it? Say yes, Mr. Samuelis. Okay, because here's the problem with bearings. It's the drawing. Once we get the drawing done, the trig is going to be one simple trig equation answer, and that's it. The trig is going to be so easy. So if you don't do that, you're causing your own problems. And if you actually literally do that and listen to me, I hope you at least get one drawing all by yourself. That you would be probably okay. Because on the first day of doing this, perennially, every single year, this is a problem trying to get these drawings done. All right. If you get 2, 3, you're awesome. 4, you're just out of the. You'll get an A+ on the next test. It's going to be no problem. But I'm hoping for at least 1 if you actually test yourself and do that. Okay, so what I want you to do is try it now. You don't start drawing right away, though. You read, maybe reread, and try to get where everything is in relation to each other. So I'll let you do that real quick. I'll be right back, computer. This might help. That won't help. That'll help. Then I use my melodious voice to read for you, like Mr. Samuel's telling stories. Oh, I gotta print this. I gotta have myself enough time to do that. Okay, first of all, radar stations A and B are in an east-west line. We should instantly draw that. So what are they? Right, left of each other, or up, down? What a silly question. 3, 2, 1, go. So you have one segment right and left. You at least started there. Stop! Hammer time. You don't know for sure, though, if A is over here and B is over here, or B could be on the left side and A could be on the right side. Just because they say A first doesn't mean A is on the left. So the next thing you should do is make sure you read the next part correctly. And I'm going to do this. Maybe I did this better with fifth hour, like to get them to get the right answer here, than fourth, because fourth was terrified to answer. All right, station A detects a plane at sea on a bearing of. So this is, and I remember having a problem when I first saw this in 09. I've taught CAT since 1996, I believe, or 95. But I think the first time I've ever seen a bearing question was at Lockport. And that was like 08, 09. I'm like, whoa, okay, hold on a second. So station A detects a plane C on a bearing. So that means from A to C. So that means you put a crosshair on A. You put a compass. You put a north-south, east-west cross on A, because that's where the plane is in relation to A. That's where C is on the piece of paper. So here's what I asked fourth hour. Didn't get much of an answer. Fifth hour is better. Where is C? Is it, first of all, above or below A on your piece of paper? Because we're looking at this as a bird's eye view. Above or below? 3, 2, 1, go. Above. I had a lot of belows in fourth hour, and then fifth hour is a little better because I think I explained it like that. It is above because 61 degrees is just this, and then boom, that's where it is. And I already gave it away. Where is C? Right or left of A? 3, 2, 1, go. Right, because I just did that. So it's right and above. So you gotta right now have to say A is here and C is somewhere out here, at least in relation to each other. And I tell you, when I get these drawings, someone will have A over here, C over here, B on another person's paper. What are you doing? All right, the drawing is not even close, and everyone's drawing has to be almost exactly the same, where everything is in relation to each other. Station B simultaneously detects the plane on a bearing of 331. Where is the plane compared to B? Above or below? 3, 2, 1, go. Still above. Where is the plane compared to B? Left or right? 3, 2, 1, go. Left. Hallelujah. Which is just a general word of praise. Nobody try to cancel me because that's a particular religion. You can't say that. Wrong. All right, here we go. That means A is over here and B is over here. So it is A is left of B. Cancel, cancel. So here we go. Sorry, 61 degrees, and you need to write this. And you don't need to get a compass. And is it a compass? No, it's not a compass. Wrong. Protractor and measure this. So you put 61 degrees here, and you draw. But I'm not going to put the plane yet, and they did call plane C. It's somewhere in this line of sight, because what I have to do is get B's, direction angle, and then it's the cross, the intersection of the two lines of sight. So don't draw C's point yet. All right, that might have given you a problem. Where do I put it? It could be here, 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 here. I want to really make it work for B. So on B, okay, sorry, I actually didn't do the first thing. I didn't draw the 3.7 kilometer distance between those. All right, now on B, I could do the 331, and this is why the people were able to tell me that it is above, because 331 is greater than 270, knowing how to draw the first way of doing a bearing, which is only off of the north axis and only clockwise. There is only one thing. So 331 is, I don't know, you could really try to get specific. This is good enough. Boom, that's where C is. It's the intersection of those two lines of sight. So do understand, everybody's drawing must almost be exactly the same. Now, I'm not going to measure angles. I'm not going to measure what's this. Is this really the angle it should be? No. In relation, C should be up and in between A and B and above. All right, don't forget to put 331 here. And now it becomes a geometry situation. You're lucky. This doesn't happen often, but these aren't a direct east-west line of each other. So now we can start finding angle measures. Like, what's this angle measure? 3, 2, 1, go. 39 is too much because that gives me a hundo. 29. At least you're doing the right thing, but you just 10 too much. That should equal 90 degrees. Again, it's only because this is a direct east-west line, these should add up to 90 degrees. They should be complementary. Okay, do some math on this one. What's this angle measure here? Well, this is 270. What's left over to get to 331? 3, 2, 1, go. 61. And now this is why we are going to have chapter 7 bearings. I'll tell you why after I tell you what happens in this one. We're stuck in chapter 2 with, I got to turn off. I think I'm getting family messages. I don't want to make you mad, but Manuka High School is remote tomorrow already. They've already made the decision. We have not. So it's probably my daughter's chiming in about what's happening. But this is chapter 2, which this adds up to 90. So yes, this is a right angle. And it has to be because that's all we have is SOHCAHTOA to solve triangles. Chapter 7, quite frankly, is about non-right triangles. Really makes me sad. I don't think you've done the law of sines and the law of cosines. Have you ever heard of that? Raise your hand. No? That's a bummer. That should be in the curriculum, but whatever. But that's what you're going to see. At least we'll get it's really not that hard. It's actually a nice little chapter. But now, when we get into non-right triangles, you're really going to have to know how to do bearings because you will not get right angles, and you're going to have to do math in order to find what that angle measure is there. But we kind of had to do math anyway to get that one. So that's one way of doing it. And I guess we have everything we need. I guess I should have read find the distance from A to C, which is B. Now watch. This is so easy now. I've picked this all day long because it was the first angle that I found. I could have used 61 though. What side is this no matter what? 3, 2, 1, go. And then what side is this? 3, 2, 1, go. What deals with adjacent hypotenuse? Cosine. Look at how easy it is to solve this. And then I'm going to make the point of those that don't listen to me, those that take this question that maybe was in the book and then just look at this picture that's provided. Remember what I said? I gave you all the pictures provided questions. Well, I don't have to read that. I could just look at this picture that's provided with the question and say, oh, it looks like they need me to find B. Well, okay, I could use 61 and that's opposite. And I could just solve that like I'm in a sophomore in math 2. And that's the point. You're a sophomore in math 2 if you just go right to the picture and don't even read the question. All right, it is true. All right, and that's why I purposely gave questions that don't that do have the drawing so that you can test yourself on getting the drawing accomplished. All right, and I really hope that you embrace that. All right, I only got one more. We got 231, and then those that are watching the video, you must wait. And I'm going to let the people in question here have a moment to try to draw this themselves. So you go ahead and do the reading. This is the last example. Then I got to make some copies. Maybe during this I'll hit the copy print thing, freeze it. I can find, what have I done with the controller? There it is. I think I still have this up there. Freeze. Nice. Okay, you guys online. freeze the video because you're going to see me. I'm going to check my email real quick. Has anything been decided yet? Oh. Do I still have this? Darn it, I don't. Maybe it is in this, though. What the heck? Oh, there we go. Ah, can't do it. You gotta wait till I'm done. All right. All right, my first question is, again, remember I admitted that this was kind of tough when I first looked at this, and I didn't associate, and all of us together were working this as math teachers back in the day. It's from and to, so the bearing from A to C. That means A gets the crosshair. So where is C compared to A, above or below? 3, 2, 1, go. South is below, so everyone should be saying below. That means C is below. And then therefore, east, which way is C, right or left? 3, 2, 1, go. So right now, I know A is here. When you read, you kind of, all right, I know A is here and I know C is here. All right, and no one can really see me up there. Why am I frozen up there? Oh, I froze the screen, that's why. All right, but anyway, they see me on this live video. And then the bearing from A to B, so it goes back to A. From A to B is north 84. So where is B, above or below A? 3, 2, 1, go. Above, and right or left? 3, 2, 1, go. So here's A, here's C, here's B. You already have an idea where everything is. This is why people that don't have those in those positions, I know your drawing is totally cattywampus and not even close to being correct. So I'll go live on this one. So here's A. I want to start with A like somewhere in the middle here because I need something above and below it. Here's A, drawing a crosshair. Here's the first, south 52 east, a little bit more than 45. And then I am going to make a mark for C. I am going to put C there and lock it in. All right? It's the next one I want to slide. And I'm glad it's north 84 east because here's the north axis and 84 is almost 90. So B is like somewhere on this line of sight. Now, what I waited for was this. Okay, now I'll put the letter B up here. The letter B? But I don't know exactly where it stops. Because obviously C is below B. But now let's look at the last thing. The bearing from B to C is south 38 west. Where is C? Is it left of B or is it right of B? 3, 2, 1, go. Left. So B's point should be like somewhere over here because when I put, and it might be helpful that because these lines cross over each other, I got to put this crosshair on here, which is not related to the line of sight line from A at all. All right, there is no correlation between those two. It should be less slanted because 84 is almost 90, but it is not. So it is not due east at all. All right, so I did kind of show that. And then south, this is 38 degrees. If you got a protractor and measured that, that's probably not quite 38, but we're going to say it is. And then here's where chapter 7 is going to come in. Oh, and actually I'm terrible. I did this to myself fourth hour, and then I panicked because I didn't have these here. And then without having these written, I couldn't find another piece of information I needed. So you got to really mark those angles. You don't mark them, then you're going to be like Mr. Samuel's fourth hour panicking. Wait a minute, I don't have near enough information to figure out what's left over. So here's what you're going to have to do in chapter 7. You cannot assume a right angle because it's not going to happen in chapter 7. You do have to draw a crosshair on C and ignore all the lines of sight. Fumble. Actually, and that's wrong too, ignoring the lines of sight. Because watch. Line of sight. Boom. What's that measure right there, that yellow sliver? 3, 2, 1, go. 52. These are alternate interior angles. Why did I put? Whoa! That's a brain gasket. I just blew a brain gasket there. I'm back. Okay, and then What's this angle measure, this little blue sliver, now that turned green because blue and yellow make green? What's that sliver right there? 38. So luckily, and you will get lucky, some of you, that you assume the right angle, but it is a right angle because 52 plus 38 is 90 degrees. In chapter 7, that angle will not be 90 degrees. And you will have to do the alternate interior angle thing to find out what the total sum of that angle measure is. And then you'll do non-right triangle trig to solve for it. So I do want to make that point. The chapter 7 bearing questions are almost exactly the same as the chapter 2 ones. All right, and then I'm missing an angle measure. You cannot, this angle is not, 90 minus 38, because all of this up to this green line is that. What we could figure out is what's this little sliver right here? What is that little sliver right there? Not 4, but 6. And I guess we could figure out this little sliver right here, whatever, because this is 90 and this is 90, right? 90 and 90, right? Or what's this whole angle measure from here to here? So what do I have to do to find this big sliver right here? This 180 minus those other two. I don't care what you need to do. It's basic geometry to figure out that this whole angle measure from there to there in this enclosed triangle is 44. So this is 6, this is 38. 6 plus 38 is 44. Or do 180 minus those two. It is basic geometry, right, to find that last angle measure. And now that we've done that, they want you to find from A to C, which is B yet again. So now that I know 44, it's a cosine of a 44 equals B over, oh no, I forgot something. A plane flying from A to B flies 250 miles per hour and it takes 2.4 hours. Grade school. R times what letter equals D? Come on. R times what letter equals D? What's the letter? T. What's the R stand for? Rate. What's the T stand for? Time. What's the D stand for? Distance. So the distance from A to B, because it does say that here, from A to B, is whatever 250 times 2.4 is, which the other hours told me was 600. Okay, so B over 600. And then you multiply both sides by 600 times the cosine of 44. All right, I got to make my prints. Movie's over. Hasta la bye-bye.